Okay, Math 9. Here we go with Chapter 9. This is Representing Inequalities, Section 9.1. And just follow along with me in your book and write down some notes when we do examples, and you will love this. Okay, so it starts, the official rule book of the NHL states limits for the equipment players can use. One of the rules states that no hockey stick can exceed 160 centimeters. So we're going to look at how we can represent that mathematically. So down below it says, show how you can use a number line to graph lengths of a hockey stick in centimeters. So if we were doing graphing length of the hockey stick in centimeters, we're just going to make a nice little line with our straight edge. And, well, we can have lots of different lengths of hockey sticks. It says that no stick can exceed 160 centimeters. So on my little number line, I'm going to say 160 centimeters here, and then that's going to be the end of how far that I can go. But I could have lots of different ones. I could have all the way down here to, I guess 0 would kind of be the end, and then I don't think I would really have a hockey stick if I had 0 centimeters. That wouldn't make much sense. So let's keep going with what they say. Use a convenient scale. We're not going to worry about the scale. Why did you select the scale you chose? We didn't. Mark the maximum allowable length for the stick. We did. Consider the rule about the stick length. Identify 3 different allowable stick lengths that are whole numbers and 3 that are not whole numbers. Well, we could put like 100 centimeters or whatever here for a shorter stick. And we're going to just let this whole thing be in centimeters and not put our units on our number line. I could have 110, 120. We're not going to put 3 on there. And then they say one that is not a whole number. Well, I guess down here I could have a stick that's 67.3 centimeters. Something like that. Think about all the possible lengths of the stick. Well, tons in here. Not this 0. And describe where all of these are located on the number line. How could you mark the values on the number line? And give 3 examples, next page, of sticks that are too long. Well, up here would be sticks that are too long. They're past that 160 centimeters. And then number 4, it says the value 160 centimeters could be called the boundary point for the allowable length of the hockey sticks. So boundary point. And on the next page, we're going to talk about what that boundary point is. First of all, before we turn the page, I'm just going to do a little bit more on this number line. We're not going to include 0, but I guess our hockey stick could come right up to 0 if we wanted to make a miniature hockey stick, I guess. And then we could have all of these values in between here up to this guy. So we'll darken that in so it actually looks like a line and not just the continuation, because there's the rest of our line that keeps going, and we are not using those parts of the number line, just in here. Okay, just take a look on this page. Let's see if I can get it so you can see it. Inequality. So a mathematical statement comparing expressions that may not be equal, and we can write those as less than, greater than, less than or equal to, greater than or equal to, not equal to. They don't have this in your book, but equal. And then if you have the kind of curvy equal sign, that means about equal to or approximately equal to. And you see here on my book I have you must memorize that this symbol means less. So squished L is less than over the page. Okay, at the top they do all the wording with this in case you're uncertain. So those are definitely ones to memorize if you haven't already. Then the boundary point, so down here, boundary point separates the values less than from the values greater than a specific value. May or may not be a possible value in the solution. An open circle shows that the boundary point is not included in the solution. So that's what we did on this one. So the open circle means we don't include 0, but right up to there. And then it says a closed circle shows that the boundary point is included in the solution. Let's just do a couple examples of boundary points. So if I was to do x is greater than 5, and I'm just going to do a scrappy little number line for each of these. So there's my number line. I'm going to say 5 is right here in the middle, so it's easy for me. And I need all the values that are greater than 5. Well, 5 is not included, but I need everything above that. And if you want to kind of draw a line above here so that you feel like you can for sure see it, that's a good idea as well. Maybe I'll do that and it looks a little more clear. If I did x is greater than or equal to 5, I would have, here's my nice little line, here's my 5, and now because of the equal, I'm going to include that 5, and then I want everything above. Notice if I put my x on the left side, then the arrow points the way it's going to actually go on the number line, which is convenient for us. And I'm going to do it a little above here so we can see it. And there we go, and we'll have the arrow to show that it continues. X equals 5 will look like just a dot on the 5. And I'm going to be lazy and only mark points that I need. So I don't need to mark -1, 2, 3, etc. If I do x is less than 5, pause and give that a try in your notes. Okay, and now let's look if you did the same thing. Less than, so it's not going to include that. And then I'm going to go less, which will be pointing to the left, like a little arrow. Look at that. How nice. And then if I do x is less than or equal to 5, do that one. Okay, and let's see if you got the same thing. So I'm going to include 5, and I'm going to go less than 5. Okay, that gives you all your boundary points, and that's just what they mean with that word boundary. If we look at the next page, 343, in the green box, it says, in many provinces, you must be at least 16 years of age to get a driver's license. Sketch a number line to represent the situation and represent the situation algebraically. Okay, so if I've got my number line, and here I am waiting to be 16 years old, I'm going to put 16 nicely in the middle for myself to make it easy, and I have to be at least 16. So 16 is included, and I could be 17 or 18 or 19, anything above here. B part, represent the situation algebraically. So x, or my age, that's what I'm thinking, has to be greater than or equal to 16. And look, there's my little arrow pointing the same way as the number line. Okay, over the page. This is 344 in the green box. A part, express the inequality shown on the number line algebraically. So if I look at their number line, they are highlighting the red part is what they mean will be the numbers that they're including, and we have to decide what they're going up by on their graph. So they've got negative 140 up to negative 130 that they're showing. And we've got 1, 2, 3, 4 lines in between. 2, 3, 4, and you're not going to do those perfect at all. It's too much time. And then we're here. So let's think. If we're going by twos, negative 132, 34, 36, 38, 40. Yes. So negative 132, 134, negative 136 is this guy. And we want to represent that algebraically. So x is going to be greater than, not equal because it's an open circle, we didn't include it, negative 130. So our arrow line, our greater than symbol, points to the right. B part, give it a try. Represent the inequality n is less than or equal, nope, just less than, negative 12 on the number line. So there's my number line, and I'm going to put my negative 12 right there. Less than negative 12, so it'll come right up to, but won't include, the negative 12. And I'm going this way. So there we go. That's all my values that'll be less than negative 12. C part. Write an inequality for the values shown on the number line. Describe a real-life scenario that the inequalities might represent. Oh my goodness, this could be so exciting. We are doing starting and including whatever they're choosing for here. 0 on the left. They've got 1 up here and 1, 2, 3 lines in between. So here's what I'm thinking. 1, 2, 3, 4 lines to get to 1, which means my denominator is going to be 4 when I'm thinking in parts of the line. So I'm over 1 line, which means I'm over 1/4 is here, and then I am going downward. So x is going to be less than or equal to, because I have a closed line or a filled in solid line, less than or equal to 1/4. And I could think of, I don't know, something super wonderful for a story. D part. Show the possible values for x on a number line if negative 7 is greater than or equal to x. Okay, this is not conventional to write in this order, and sometimes we do, but you just have to read from the x all the time. So this says x is, and then you're going to read backwards, less than or equal to 7. So this is exactly the same as x is less than or equal to negative 7, sorry. Negative 7. And show the possible values on a number line. Okay, here we go. So there's going to be my negative 7, and I'm including it because of the equals. Less than or equal, I'm pointing to the left. So I want all the values going down that way. What is a different way to express negative 7 is greater than or equal to x? Well, we already did that, and it's this guy with the x first, which is most conventional. And next page, last question. So green box at the bottom of 345. The most extreme change in temperature in Canada took place in January of 1962 in Pincher Creek, Alberta. Here we go, the question for southern Alberta. A warm, dry wind known as a Chinook raised the temperature from negative 19 degrees to 22 degrees Celsius in 1 hour, which we're not really surprised by that because we know that can happen. This is a little aside. When I was in high school, we had a Quebec exchange, and we went there, and they came here. When they came here, it was February, and we had a big snowstorm, and then in the night we had a chinook, and in the morning the snow was all gone, and none of us thought anything of that, except for they thought a lot of that because that had never happened where they lived. They had never experienced that. And Dallas, living in Edmonton, and I had heard this, but she said it's totally true. Like, it just snows and it just stays and it never leaves until it's spring or summer because they don't get Chinooks, which, whew, I'm thankful. Thankful for the wind. It's a good thing for warmer temperatures. Okay, represent the temperature during this hour using inequalities. Express the inequality verbally, graphically, and algebraically. Okay, so let's draw. We have our nice temperature, and we're going to make a good enough graph because we don't want to spend forever making perfect lines. So here we go. Negative 19 is going to be here, and then it went all the way up to 22 degrees. That's a lot of change. That's like more than 40 degrees. Holy cow. In 1 hour. And here we go. So we include the negative 19, we include the 22 degrees, and then we are everywhere in between there. We won't put arrows because we're quitting at those points. And express verbally. So if we were to write this, we would say everything greater than or equal to negative 19, and at the same time less than or equal to 22 degrees, or we would say in between negative 19 degrees and 22 degrees, including them both. Represent this graphically we did, and algebraically now. So 2 ways we can write this. If we do it in 2 parts, we're going to say x is going to be greater than or equal to negative 19, and at the same time, so comma, x is less than or equal to 22 degrees. This is more commonly written in one little math sentence as an in-between. So here's how you do that, and you'll see this lots. Negative 19 degrees is less than or equal to x, less than or equal to 22 degrees. So if we read from the x, that says x is greater than or equal to negative 19, which, yep, and read from the x again, x is less than or equal to 22 degrees. Ta-da! Okay, have a good time, do your questions, and we will see you tomorrow.